They can hear me. Great.
Hey, well, great. I'm not going to spend a whole lot of time. I just wanted to welcome everybody. It's really kind of interesting that it's like the last week of school, and it's our first seminar of the year, which is kind of unfortunate. But I'm really pleased to have Rochelle here today to talk about her work, and so we get to really dig into something. I really like these work in progress, which is right?
Yep,
so
absolutely.
Rochelle's going to want feedback for us. So questions from, we actually have people in the audience. So this is great. We have masks on, but it's okay. I'd rather see people with masks than not see people at all. So welcome everybody to our first and our last seminar of this school year. And next year, we're going to be back in force. Hopefully.
Yeah, thanks, Joe. Thanks for that.
Thank you. Thank you so much.
Yeah. Thanks for that warm welcome. And I'm also excited to be back in person in our new normal, what it means to be new normal. So I'm really excited to share out what my team has been up to. And like I said, I'm even more excited to do this in person. I started my faculty role in August of 2020. And so finally get to meet people in person on campus is really refreshing. As such, I would like to use this opportunity to give you all a sense of who I am, as well as present what me and my team have been working on with respect to developing a mixed methods approach to study complex motivational constructs. And so an outline for today, first I'd like to give a little background about myself. After that, I'll give a general overview of the project that we've been working on, specifically some motivation and aim, as well as who is working alongside of me. Then since it's been a long couple of years, I'm sure for all of us, I framed this talk around the evolution of our research design. And through that, I hope to describe to you the methods that we've implemented in that design. And then I'll end with some plans moving forward, both with future analyses within this specific project, as well as where I could see this fitting in other contexts and for other constructs. So who am I? I'm originally from Pittsburgh, Pennsylvania. And of course, being from the city of champions, I'm an active sports fan. The Pittsburgh Penguins just had their first playoff game last night and they won in 3 overtimes. And I was still working on this talk, so I was really excited about that. I did my undergraduate education at a university called Slippery Rock University, which is about an hour north of Pittsburgh. There I was a student athlete majoring in physics and playing second base for the Slippery Rock softball team as an academic All-American. I then went on to do my graduate studies at West Virginia University, where I did my master's degree in kinetics matter physics, specifically working on the growth and characterization of topological insulators. And about halfway through my graduate career, Professors John and Gay Stewart were hired at WVU, which gave me an opportunity to do what I really loved, which was physics education research. And so my dissertation was entitled An Exploration of Diversity and Inclusion in Introductory Physics, where I used large multi-institutional data sets and advanced psychometric theory to really understand the persistence differences between male and female physics students in terms of their performance as well as their self-efficacy. I landed here at MSU in 2018 as a postdoctoral researcher under Danny Caballero, who's here in the audience. He's on tenure, so thank you for coming. Or sabbatical, sorry, he's tenured on sabbatical. So thank you for coming. Most of my work during that time was centered around developing formal structures to support the newly transformed physics labs, specifically developing assessment tools and practices for understanding student learning in what's called the data lab over here in the physics department. So I explored student understanding of measurement uncertainty, as well as how the transformation impacted student epistemological beliefs about experimental physics. In addition to some of that work within the data lab, I spent some time investigating student achievement and persistence utilizing registrar data and large quantitative methods. This year was a project I worked on with one of our graduate students, Cami Monsalve, which explored the degree pathways of students of color with transfer credit, where we found it promising that large populations of Black and non-Hispanic and Hispanic students who have any transfer to your college transfer credit are succeeding at obtaining a bachelor's degree at MSU, which is a primarily white institution. During my postdoc, I was also finishing up a side project that I had started in graduate school. This was a part of a larger project happening at WVU, which was leveraging motivational theory in studying student retention. My piece was centered on using social cognitive theory to chart gender differences in the development trajectory of STEM self-efficacy. A large piece of this work was me developing a domain-specific self-efficacy survey to then chart those gender differences across those various domains. And so, for example, when I say domain, I mean, self-efficacy towards their current physics class, their current math class, their other science classes that they're taking, their major, and their intended career. And so we found that the only differences between men and women were in the current math and physics self-efficacy. And these differences were evident very early before any class feedback was given or was received by the students. And the evolution of the self-efficacy was the same for men and women across the 2-semester sequence of physics. And so now I'm a faculty member jointly appointed here in the Department of Physics and Astronomy and the Create for STEM Institute, where I work alongside some really wonderful people. My home is in the Physics Education Research Lab over in the Physics Department, where we now have 6 faculty, 4 postdocs, 10 current and incoming graduate students, and then many other undergrads that work alongside with us. And so from all my experiences through the academy so far, I think the question that really holds my work together is how may the practices of STEM education be redesigned so that they more effectively foster interest, competence, and persistence in the sciences while securing a growing, more diverse population of STEM qualified graduates. So when people ask me what I do, I like to say that I'm a quantitative physics education researcher who uses a DEI lens to explore assessment and evaluation within physics classrooms, as well as STEM retention and attrition, both at the unit level as well as the college level more broadly. And so today, I'm going to focus on the STEM retention strand of my work, as I see that this is the place where this particular project fits in. So let me give you an overview of the project, particularly some motivation and aim, as well as who are the people that are working closely with me. So a piece of work that I always come back to when I think about retention is the 1997 Seymour and Hewitt book entitled Talking About Leaving, where they discuss the education research that was being conducted to understand why students are leaving the sciences, right? And here, Seymour and Hewitt, I think, do an excellent job avoiding the victim blaming and point the reader to strategies beyond fixing the students to diversify the STEM community. And so many of us that were wondering why students were leaving the sciences began to think about, what about our teaching is pushing people away? And are our institutions providing the needed supports to all students on campus? And although you might say, right, this book is a little outdated, right, 1997, it doesn't seem like a while ago, but it's a while ago. Just recently in 2019, folks in STEM education revisited this topic, and these arguments are still evolving today. And so even though there may be some improvement, there's still work to be done here. And so historically, researchers who talk about retention have leveraged different types of models when they're exploring this phenomenon. They've leveraged educational retention models such as Tinto's model and Bean's model. And even though those are also somewhat historic at this point, a little bit more recently in the early 2000s, folks have argued for utilizing motivational theory models, which they want to integrate the motivation and cognitive models within that research. And so in the early 2000s, there were a couple of really nice papers that I think could do a good job outlining these two types of models. and what psychosocial constructs are salient from these two perspectives. And so, for example, in the educational persistence model, these include things like contextual influences such as financial support and size of institution. And the motivational theories include things like achievement motivation, self-efficacy, and outcome expectations. And what I really like about this, this is a meta-analysis, is they demonstrated that the traditional predictors such as high school GPA, ACT scores, things like that have a strong correlation with student retention. And the other psychosocial variables also have been shown to have a strong correlation with student retention. So here, for example, the ACT score shows a 0.12 correlation with student retention, and academic self-efficacy shows a 0.26 correlation with student retention here. Speaking of ACT, in their 2004 policy report, they explored the role of these non-academic factors in improving college retention, and stated that the combination of the academic and non-academic factors have the strongest relationship to college retention. Now, these are two models, the educational retention models and the motivational theory models, are still really present in today's literature, right? And I'm not here to debate which of these theories or models is the right one. That is totally not my expertise. My work is driven by how do we measure these things that are within these models. So for example, an ACT score might be obvious, right? It's a given measurement after a student takes, this assessment. But what about the psychosocial factors that are also important to these retention models? How do we measure those? Okay. And so since I'm a quantitative researcher, a lot of stuff that I read for various psychosocial factors leverage surveys as their tool of measurement. And researchers sometimes will use a one-time measurement, right, to look at things like differences across groups, or use them in a regression analysis to predict some student outcome. Others may use a pre-post design and to explore, let's say, over an academic semester to investigate, the impact of some intervention or some, small curriculum change that they may have made in a classroom. And so, for example, this is a one-time survey measurement that's leveraging a survey intended on measuring student identity, specifically engineering identity, to predict a student's persistence within engineering. So here they have in model 3, they have their control variables, and then in model 4, they add the independent variables that are coming from the identity survey into their model to predict persistence in engineering. Other examples, this plot on the left shows a 4-time point measurement investigating the effect of a brief psychological intervention on a student's sense of belonging. And the plot on the right is showing shifts in self-efficacy between physics classes and other STEM classes. So shifts meaning pre-post design. And so that plot on the right is showing that, on average, we see a negative shift in student self-efficacy in physics, but a positive shift in other STEM courses.
Was this data from Michigan State?
This data actually comes from, we looked across many papers here and looked at the shifts. So these are on average across the literature in physics. Yes. So however, many of us who care about measurement, right, would argue that with the complexity of such psychosocial constructs, a one-time measurement or a pre-post design may limit us in deeply understanding the impacts of the curricular or co-curricular activities that they have on students, right? So for example, Zuzanic might say these methods may lead to potential for failure of recall. And Lee would say that over-reporting and under-reporting certain behaviors is easier and maybe more tempting for students in a one-time questionnaire. And so now there are techniques, right, that can minimize, quantitative techniques that can minimize some of these limitations, one of which we've actually leveraged in our project called the experience sampling method. I will eventually get into the details of this method a bit later, But I would like to acknowledge one of our own colleagues, Jen Schmidt, here on campus, who wrote an outstanding book about this method, and I believe she still actively uses it in her research. And so generally, I think for me at least, one large limitation in quantitative research is there is limited opportunity to get into the fine-grained details about a student's experience, right? And so if I turn to the other side of the coin and talk with my qualitative friends, right, I think most of them would say that a lot of their qualitative measurements, particularly around these non-academic factors, leverage reflective interviews to maybe explore, student experiences over a semester or an academic year, or some may leverage open-ended surveys to look over a broad set of experiences. So, for example, the first-time student experience at a university. This here is an example by Danilak, Gupta, and Elby that follows an engineering student through a series of interviews and in-class observations, which produced a case study to characterize the epistemological aspects of the student's identity and how they influenced his perception on his engineering program. And what they found is that the student expressed and enacted a sense-making epistemology that is fundamental to his identity as a learner. And because of this, he often felt like he didn't belong in his program and actually considered leaving engineering. And so just like in quantitative measurement, there are some limitations to the qualitative methods that are traditionally used. For example, a distal reflection may limit us connecting what particular event may have impacted a student in the moment, right? Participants' memory can change over time. Also, these methods can show the presence of some psychosocial characteristics, but it's difficult to pull out the size of that impact of something on, let's say, a student's self-efficacy or sense of belonging or whatever construct you may be interested in, right? So, for example, right, a reflective interview might tell me that an advising meeting changed the way a student talks about their experience through their major, but it's difficult to link the actual advising meeting onto the impact of their self-efficacy, sense of belonging, whatever you're looking at. And so when thinking about what it means to measure these quite complex psychosocial constructs, I see personally a need here to develop a research design that can be both useful for studying these things while mitigating some of these limitations that are present in the more traditional approaches on both sides of the coin. And so broadly, that is what my team is really trying to do here. So when I start to talk about my team, I should probably begin with how this all started to allow some specific context of what we're trying to accomplish here. So as I mentioned during my postdoc, I was finishing up some of the work centered around student self-efficacy or the confidence in one's ability to successfully perform a task. And it turned out that I had, and I continue to have, a fellow colleague and dear friend, Vashti Sautel, who's also in the audience and on sabbatical, so thank you for coming, who is an expert in self-efficacy theory and has been studying it over the course of her career as well. And so I hope I'm representing this well, but I think what holds our interests together is that we really care about knowing how to best support our students. And since we know that it's been shown, self-efficacy has been shown to be a strong predictor of achievement and in science courses and persistence through the major and in their career, we should really be thinking about how to better support students' development of their self-efficacy over time. Okay. And so I think it's fair to say that we've done some of this work independently. Vashti developed a qualitative method to analyze the development of self-efficacy in real time. And I developed a domain-specific self-efficacy survey to chart the gender differences in the development trajectory of their STEM self-efficacy. However, I also think it's fair to say that we both recognize the limitations to our work, which connect back to the limitations that I had previously described earlier when we start talking about quantitative separate from qualitative. And so through many we'll say formal and informal discussions, we decided that it would be a good idea to put our efforts together and come up with a mixed methods research design to study the complexity of the development of a student's self-efficacy while hopefully mitigating some of the limitations we saw in our work at the individual level. And so in the spring of 2019, we wrote an NSF proposal, a collaborative research proposal entitled Building Self-Efficacy Theory and Methods to Describe Developmental Patterns Within and Across Boundaries, with this long-term goal of developing a foundational theory on how self-efficacy evolves over time across disciplinary and institutional boundaries. And while we got right, they rate these things, right, with this language of very competitive, right? The review identified a weakness that was centered around the establishment of validity and reliability of the data generated from the measures being made. And so as a logical first step, we defined a short-term goal of building the methodological and measurement tools necessary to examine self-efficacy. And we decided to focus in on students in science and math classes who transferred to MSU from two-year colleges. So really having our long-term goals of across disciplinary and institutional boundaries in mind. And so this encouraged us to apply for some internal funding through both the MSU discretionary funding initiative in 2019, as well as some seed funding here through Create to really build these tools that we had envisioned in that proposal. And so over these 3 years, remote years, of building this method, we've had many folks work with us. We had a couple of graduate students, Alyssa Watterson and Laura Wood, do some of the early work as a side project while working toward their dissertation, their own dissertations. We have Carissa Myers, who's currently working with us. She's a graduate student who joined the team, and her dissertation is solely focused on this design. Ben Maves, he's an undergraduate student who's been helping Carissa with her work over the last couple of semesters. We have a couple of folks joining us in the summer, Dana Azadi, who's a postdoc in Pearl, and John Bird, who will begin his graduate work next fall. And so just to say explicitly, I really could not give this talk without all of their efforts on this project. And so I would really, really like to just recognize them. So now that I've set us up with this short-term goal of building the methodological and measurement tools necessary to examine self-efficacy for students in these science and math classes who transferred from MSU from a two-year college, I want to walk us through the evolution of our research design. So the elements to this design include the experience sampling method, or ESM, which I briefly mentioned toward the beginning of the talk. And that is coupled with daily journal prompts and reflective interviews. And so with the internal funding that we received from the MSU DFI in the fall 2019, in spring 2020, we ran our first study, which I will refer to as our pilot study. And as you all know, in March 2020, we transitioned abruptly to remote learning. And so this study was, in fact, interrupted due to the shift. But because students are amazing, we did get some results out of this pilot study. Our sample here consisted of physics majors who are currently enrolled in upper division physics courses and had transferred at least 1 credit from a two-year college. And so we invited 9 students, of which 5 participated. And our idea here was to explore this ESM, the experience sampling method, coupled with some reflective interviews to really investigate the students' experience with the ESM tool, because neither of us have ever used that tool. So we wanted to see how the students really responded to using the ESM. And so before I get into the details of those results, let's take some time to just describe briefly what the ESM looks like for us particularly. But generally, the experience sampling method is a means of collection of information about both the context and the content of the daily life of an individual. And so specifically, it asks individual to provide responses to both open and close-ended questions at random points throughout each day. And it has the ability to really capture a student's daily life as it is. It was developed in 1970 at the University of Chicago to study everyday experiences using journaling prompts. You'll see a lot of this methodology in psychiatric and psychological treatment studies. And in my field of physics education research, it's recently been used within the physics discipline by Nissen and Shemwell to study high school students' experiences with interactive engagement within the classroom. And so in our context, we are using it to measure a student's self-efficacy. So what does that actually look like? We utilized a phone application, which this is showing the original application that we used, but we have since transitioned, where our students are randomly notified throughout the working day. So Monday through Friday, around 8 a.m. to 6 p.m. For generally a 2-week period. And during each of these random notifications, we ask them to answer a short survey probing at what they're doing in the moment and their self-efficacy toward those activities that they're reporting to us. And so specifically, what we've asked, we first asked open-ended task level questions. And so what is the main thing you are doing and where are you doing this activity? We then probe their task level self-efficacy from items that we adapted from previous work, right, Nissen and Shemwell's work, which asked on a scale of 1 to 5, how skilled are they in the activity, how in control they feel in the situation, and are they succeeding at what they're doing. I have these scales in brackets because we started with a 1 to 5 scale, and we've since changed to a 0 to 100 scale. So the questions are the same, the scale is just a little different. The students are then asked if the activity that they were engaged in was for a course that they were currently enrolled. And if they said yes, then they received 3 course level self-efficacy questions. And if they said no, they received 3 career level self-efficacy questions. And so these course level questions and career level questions were adopted from my previous work that started at West Virginia with the domain specific self-efficacy survey. And so for our work so far, we've really just been focusing on the task level questions. So what it is that the student is doing in the moment, and then their self-efficacy toward that specific task. And so to give you a flavor of what the data output looks like from the ESM, here's an example from the paper Vashti and I wrote in the summer of 2020. On the y-axis here, we have a student's task level self-efficacy. On the x-axis, we have the notification number, and the 3 different lines indicate the 3 task level self-efficacy questions that the students are answering with respect to that in the moment activity that they're engaged in. The circles on the notification axis indicate if the task was course related. Now, I mentioned that the goal of the pilot study was to investigate the students' experience with this ESM tool. And so specifically, we really wanted to know more about the research incentive and more so about the integrity of the data. And so we designed semi-structured interviews to reflect upon those experiences and the incentives that we provided to the students. The interview protocol had 3 primary sections, actually. The first unpacked, right, the student's experience with the ESM data. The second unpacked the interview structure for participating in the study. And the third asked about the students' specific responses to the ESM prompts and the events that surrounded those responses. And so the latter of these sections, it actually represents the style of prompts that we plan to scale beyond this pilot study. But for circumstances, we'll say, we decided to focus solely on the ESM experiences and the incentives. And so what we found with respect to the research incentives was that our incentive structure of $50 a week for responding to approximately 80% of the notifications, on average, 5 students in the 5 students that participated in our study had a overall an 85% response rate. And when asked about this in the interview, respondent 987 says, the way I thought of it was just kind of in terms of how much time I spent on the surveys and how much money I got from the incentives, and it was plenty of money. I didn't do an exact calculation, but it was, I probably spent less than, half an hour total each day. And I guess I would do it again for the same incentive over the same amount of time. I didn't have any problems with it, so I don't think I would change anything. And so from this student's perspective, the $50 per week was strong enough to incentivize their participation. With respect to some of the experiences that students had with the ESM, there was also evidence that the students were appropriately interpreting the questions as measures of self-efficacy, and they were answering those questions based on the tasks that they were currently engaged in at the moment. And so, for example, here in the plot, if we focus on the top respondent 980, as shown by the circles around notifications in that figure, when this student answered the task level self-efficacy questions about course-related activities, their responses indicated that they mostly respond with 3s or 4s. And so we asked around that, we asked in an interview, we probed around why this student selected 4s as compared to 3s, right? And so they responded with, my thought process, especially when I said I was doing homework, I'm way better in computational numerical stuff than analytical physics, I guess. So I guess my confidence interval was basically in how easily I could solve the question that was put in front of me. And so this student says that they're answering the self-efficacy questions based off of the task or the question that was put directly in front of them, the activity that they're doing in the moment. Yeah, question. There's a question. Sure.
So the first one is, so they get a notification and they respond. What's the window in which they get to respond to the notification if it's random? Is it just when the next notification comes that's considered missed, or is it like?
Yes, good question. So that has changed over the evolution of our study. I would say what the students get 45, originally we've got 45 minutes, and if they miss the notification, it's missed. They can't go back. Yep. Does that answer your question?
The second question was, the window of time that you are seeing is the work day.
Correct. Yep.
I'm curious if you were missing anything by not sampling people.
Good question. Yeah, so probably, but we wanted to kind of engage, suss out how this tool was working in the students' lives, right? So we didn't want to take over their entire life, right? And we are capturing things that you would expect to maybe capture after the workday. For example, we're capturing them eating lunch, right? Sure. And so that's kind of a validity measure of this tool is working. They might be high in self-efficacy when they're eating lunch, things like that. So, and we're capturing, homework assignments, them in class. So we are capturing a diverse set of activities in the window that we are focused on.
I was just thinking about the evening as being a time a lot of students are working on academic stuff, time for on academic stuff. And so it was kind of me thinking about, like, does the application allow maybe the student to choose, like, I will respond to
Yeah, that's a really good point. I don't know if our current application allows for that. Probably not. I think we have to a priori schedule it. But that would be interesting to take back to them. Yeah. So Vashti and I, thanks, Danny. Vashti and I wrote a paper around this idea of research incentive and data integrity, which was in the 2020 peer-reviewed physics education research conference proceedings. And so if you're interested in more details, I would encourage you to check that out. So now in the pilot study, I mentioned that a piece of the interviews were asking about the students' specific responses to the ESM prompts and the events surrounding those responses. And even though we didn't spend much time, much focus on that during spring 2020, in the fall 2020, we turned our attention to specifically trying to connect the student responses to the ESM with them reflecting upon those events surrounding that notification or that response. And so I call this pilot study version 2 because it wasn't interrupted by COVID. We were just online doing our thing. Here we invited students who were physics majors or astrophysics majors and have either transferred at least 1 credit from a 2-year college, or they were first generation college students. In the literature, there are some overlap between those 2 populations. And so we expanded a little bit. Overall, we invited 56 students, 11 of which participated. And here we continued with our ESM design of the students, right, receiving these random notifications throughout the workday, but began to couple them with what we're calling daily journal prompts to allow students to reflect upon those experiences more proximal to the activities in which they're engaged in. And so this pilot study version 2 is really where we started to build the mixed methods piece of this design. And so here we start with the quantitative data collection, right, via the ESM, where students are filling out these brief surveys, random times throughout their day about what they're doing and their self-efficacy toward these activities. But now during the data collection period, we quickly analyze these survey results, which then allows us to write daily journaling prompts, which allows the students to then reflect on those experiences more proximal to the events that they were engaged in. And so, we use these journaling prompts, right, because this allows us to probe into the in-the-moment experiences they reported on the survey close to when that experience occurred. And so this, for example, this journal prompt, it's kind of a silly example that Carissa Myers came up with. Today in the app, you told us you were making a sandwich. We noticed you indicated you were on the extremely side of the scale for feeling skilled. What were you thinking of when you answered, how skilled are you in this activity? And so a response from a student might say, I was closer to the extreme side of the scale because I've made sandwiches for multiple years of my life and they've always tasted the best, right? I'm the best at making sandwiches. And so in this example, right, we're trying to connect their response in the app to them reflecting on that experience and diving deeper into those details, right? And so altogether, 1 day of data collection looks like this, where we have, right, the quantitative piece via the ESM, we have the qualitative piece via the daily journal prompts. And so for pilot study version 2, we did this for many students, right, 11 to be exact. And so you can imagine there is a ton of data to be analyzed here in 1 2-week data collection period. Yes. Sure.
The journal prompt, is it 1 prompt per day?
Correct.
Or multiple prompts?
It depends on the situation. I would say 1 to 2, maybe no more than 3, I would say, right? Yeah, question.
So basically the journal prompts, they give you an indication whether the self-efficacy or measuring is related to physics or to STEM or
the activity that they're engaged in, right? Doing homework, right? The journal prompt allows the student the space to expand upon that quantitative measurement that we're taking, right? And expand upon that experience and what they're engaged in. Does that help?
So just to make sure I understand, the journal prompt is always in relation to something they submitted that day, either the activity or the scale, or do they get generic prompts about their self-efficacy?
Yeah. It really depends on the individual, right? These are individualized journal prompts. And so if we do see a shift, right, we would write an individualized journal prompt. But if, let's say, we don't see a shift, or, with 11 students, that's a lot of students, it's a lot of prompts to write, we'll give them a general self-efficacy journal prompt. Yeah.
Not algorithmic prompts. You're writing
Nope.
these prompts every
Vashti
day.
and Carissa are writing these prompts.
Wow, okay.
Yes.
To respond to it.
Mm-hmm.
So 11 of 56, that's like a 28% of the responses.
Mhm.
Right?
Yeah.
So how does that influence, and I assume you're still using this pilot study for validity purposes?
Yeah, absolutely. Yeah. Mhm.
So how does that limiting of the 20, how does that only 20% of the sample affect the validity?
Yeah, that's a good
Maybe it
question.
does,
Yeah, no, that's a good question. I mean, I think one thing to remember here is we were also fully online that semester. And so Yeah, exactly. We don't know. Exactly. Absolutely. Yeah. So I think, right, the participation rate in terms of our asks and those students that, or the students that are invited and the students that choose to participate, we haven't focused a lot on that. We've focused more on the participation. Once the student engages with the research project, what's their participation rate? So are they falling off? Is this too much of data collection? Things like that.
Yeah, I was just wondering, the validity, if you could get some kind of data, I mean, maybe it's too late now, but if in fact that 11, that 11 was representative of 56, then you have a harder validity, you have a stronger validity than if, for instance, they were one of the extremes.
Of course,
Or even
yeah.
if they were in the middle of the group, you have like a larger.
Yeah, yeah. That's a great idea. Yeah, we should definitely look into that. Yeah, yeah, no, thank you. Yeah, right. So yeah, so as I said, right, like there's a ton of data here to be analyzed, right? And so in spring 2021, Carissa Myers, right, a graduate student in Pearl, joined us and did the initial analysis of what I'm calling the pilot study version 2 data, right? And so as an example of some of her initial work, this is some data from a student whose pseudonym is Jane. This plot on the left is Jane's first week of the ESM data, where Carissa went through and identified the course-based tasks and specifically for which course the student was doing this task for. And so from this, she started to investigate the qualitative responses that were coupled to the individual's notifications, and really at the end of the day had some recommendations on how to strengthen this tool. So for example, if we focus in here on notification 12, which was at the end of day 3, right? And if we, this chunk here, 8 or 9, 10, 11, and 12 is day 3. At the end of day 3, we saw a shift downward, right? And we noticed a dip in this survey. And so we asked Jane, you know, today in the survey data, it appears that you had a rough patch in your day where you felt less successful and skilled than at other moments. Can you tell us a little bit about what was different from those earlier responses to the later ones, right? And Jane responded with, my physics class has a great help room and instructors, and I really feel like I'm learning and mastering the class. My physics lab is really frustrating, and there feels like there is nowhere to get help or find out information or expectations. It is just hard to know what to learn and what to study. And so again, our intent was to probe around the specific activity that Jane was engaged in. However, what Carissa noticed was that the prompt didn't actually retrieve any of the information about the task Jane was doing at notification 12, which was CMSE homework. There's nothing about CMSE in Jane's response, right? And so the other thing Carissa noticed was that Jane was clearly having vastly different experiences across courses. And so with this initial analysis, Carissa came to us with a couple of suggestions. You know, one, we should develop better journal prompts to explore the confidence students feel about a specific task in the moment. And 2, we should really diversify our sample population as we're seeing students having, different experiences across different courses. Remember, we've really only focused in on upper division courses at that time, right? Upper division physics courses. And so in summer 2021, we asked Create if they would support this continuation of this work, and they did so generously. And in the fall 2021, we ran what I'm going to call the beta study with Carissa's suggestions in mind. Okay. And so to diversify our sample, we actually requested the top 10 courses taken by transfer students and sent an email to those students, as well as the students in the upper division physics courses who we've already been following, right? And 280 students filled out our interest survey, and we had a little bit of a panic moment. But because we were only limited to a number of spots, right, due to budgetary reasons, right, we came up with a selection criteria based on, is the transfer student from a 2-year college? Are they first generation college students? What's their major? what courses are they enrolled in, right? We're trying to diversify the courses that we're looking at. And then lastly, their involvement in other MSU programs, things like Drew Scholars, things like that. And so we invited 30 students. 18 of those filled out the consent and actively participated in the study. Okay, and so we kept the same design in mind, right, with the ESM and the daily journal prompts. However, we were more intentional about the design of the prompts around the individual task that the students were engaged in. So we kept Carissa's suggestions in mind and trying to refine and revisit these daily journal prompts. So this is an example. This is some data from participant 6, where both notification 3 and 4 were centered around a research course that they were enrolled in. And the task for notification 3 was working on my research project, where their self-efficacy was 40, 66, and 62 for the 3 items. And then the task for notification 4 was putting my findings for this week for my research project into a presentation where their self-efficacy actually jumped up to 87, 100, and 83. And so as Carissa and Vashti were collecting this data, they noticed this shift, right, and wanted to probe around it. So they wrote a specific prompt around those 2 notifications. And so the prompt read, yesterday, it stood out to us that your confidence in your abilities in research course was notably higher. Could you tell us what was happening yesterday? What were you doing? Who were you working with? What impacted your sense of confidence, right? And participant 6 reflected back, what made my confidence get much higher in that course was a combination of 2 things. One of them was that for an assignment that I was given for the research project, I went above and beyond of what was asked of me and did more than just look at some of the data that I was given, but I made a full PowerPoint presentation about my analysis and conclusion off of this. The second point that gained me confidence from this was that my research mentor was very impressed and made a point to compliment many specific details about both me, even putting together a presentation, and also how I set it up overall. This made me gain a lot of confidence in myself and in my work. And so here we're beginning to see a connection between the shift that we saw in the ESM data, right, and self-efficacy toward their specific task that they're engaged in, and the student expanding upon what actually impacted that shift in their confidence. Okay, here their research mentor being one example, right, pointing out how well they did. So we're here now, right, spring 2022. We're at the end, right? This is our most recent semester. We decided to collect, we decided to continue to follow a few of our students through this mixed methods design and further fine tune the journal prompts. But we also collected what we called our large N ESM study, where we intend on looking at the validity of our survey items and how they are working on the ESM. So for this large N study, we followed the same recruitment strategy where we requested the top STEM courses taken by transfer students and sent out an email to them, as well as, of course, the upper division physics courses, which we've been following all along. This time, 176 students filled it out. And because we were doing large N and we weren't doing the person power of writing 104 individualized journal prompts, we kept 100, the 104 students were only actively engaged in the ESM work, right? So our data source was just focused on the experience sampling method to really get at, to gather some data to really validate the survey items. This analysis will actually take place this summer with one of our new incoming graduate students, John Bird. Right, like I said, we're in spring 2022. So where did we land through the evolution of this project? We have this mixed methods data collection design where we're using the ESM to collect in the moment survey data, using that data during data collection to then write specific task specific daily journal reflections. And so I would say that, through a long, maybe 3 years, we're well on our way toward our short-term goal of building these methodological and measurement tools necessary to examine self-efficacy for students in science and math classes who transferred to MSU from a two-year institution. But what are our plans moving forward? In terms of future analyses toward further validation of this method, we have folks working in a few different spaces, right? Carissa will continue to be working with us toward validating this method, this design, and thinking about our validation frameworks, as well as the affordances and limitations to this design. Dena Azadi, she's a Pearl postdoc researcher that will be joining us this summer, and she'll be working with the journaling prompts and the student responses to see if the prompts are eliciting what we expected them to actually elicit in terms of self-efficacy statements. And then, as I mentioned before, John Bird will be joining us actually this summer. He's starting early, and will be working on the ESM survey validation survey items. In terms of our long-term goals, we'd really like to take this design and use it in other contexts and maybe for other constructs outside of self-efficacy. We currently have an STEM proposal in and just got questions back, so fingers crossed. And hopefully we'll be able to use this tool to study students transfer self-efficacy as they move from the two-year college to the four-year institution here at MSU. And we also plan on writing an EHR core proposal on developing that foundational theory for transfer self-efficacy. I personally would also like to leverage this design to study graduate student retention using motivational constructs. And so adding things to this, right, sense of belonging, maybe physics identity for myself, right, and being in the physics department. And so, in physics, generally, we've done some work investigating admissions criteria, right? But at least to my knowledge, we have yet to explore beyond that and probe into the student experience through their, let's say, physics program in my context. So with that, I think I'll end there. And I'd like to say thank you to all my collaborators, especially Create for the seed funding for this project. And I would be happy to take any questions, and any feedback would be much appreciated. So thanks. Yeah, question.
Can you give a little bit of profile about those students that transfer from colleges to MSU? What are their motivations to do that in the first place?
Yeah, that's a good question. I might turn to Vashti on this one because that's your work, right?
Motivation is so most of these students are starting at institutions that they can't earn a bachelor's degree, so they have to transfer to complete their bachelor's degree program. And in the sciences, as you can see, at least and so most of the students actually enter community college with intention to transfer to complete the degree. All one.
Just now, can you just give a brief summary of the question?
Sure. Yeah. So the question was, could you describe some of the motivation for students to transfer from two-year to four-year institutions? Right? That was generally the question? Yeah. And Vashti Sautel's response was, the students at the two-year institutions can't receive the bachelor's degree. They're the bachelor's degree in the sciences, right? They have to come to the four-year institution to receive that bachelor's degree.
And all in all, they do like 6 years to get the bachelor's degree?
Good question. Yeah, I think it would, time to degree is a tricky question, but I would say probably 4 to 6 years, maybe on average. Yeah. Yeah, Danny.
So one of the things we noticed was that you all did research on the prompts, right? And so you showed an example of response and then concept. You didn't have to make changes. But what I was hoping, and I think I kind of saw it, was that there are components of the contracts that you're looking for in that response. I think I saw them, but being not expert, I wonder if you could go back and sort of show us seeing the things you wanted to see in the response?
Yeah, sure. So the question was, can we go back and look at some of these responses to actually see if we're seeing maybe some self-efficacy statements? Yeah, so I mean, this is a great point, Danny. This is actually what Dana Azadi is going to be working on, right? And trying to connect the prompt of what we intended on trying to capture with the student response and what they're saying. But yeah, so for example, during the beta study, right, even this last statement, this all gave me a lot of confidence in myself and in my work. And so explicitly saying that, the two experiences, one, making a PowerPoint presentation, and two, the advisor pointing out that they did a great job, right, increased their level of confidence toward that task. Yeah, Joe.
So I really liked, I really like the addition of these open-ended questions to the DSM. I think that's a really nice addition to give people insights into why people are responding the way they respond. So compliments.
Oh, thank you.
I'm really curious, what I really love, if you really, right now you're not necessarily really focusing on trying to figure out, like, is there a certain kind of instructional activity that really interests kids, right? That's not your focus at all. You just sort of just randomly.
And the journal specific.
Yeah, well, it could be both with, when they get the thing buzzed, right?
Yeah.
Right, you can do it like, so for instance, I know Danny's done some work to really do a lot of revision of your program, right? So it would make sense to me then, like in Danny's class, and you probably done it in your class too, like you're a specific thing, like, how does this particular activity work?
So
And do we see kids more heightened engagement as a result of putting this in? Right, and how are they responding to it? Like, I would really love, I think that would be really interesting to see if we do see a heightened thing, and then also see if their response corresponds to the thought.
So in our designs for the proposals that we are putting in, it is more intentional. Actually, some of what Danny suggested earlier, like when should we ping the students, is based on actually information about the cohorts and stuff that these students are part of, so we know what kinds of experiences we can anticipate.
Yes.
Impacting some of it. But right now, what Rachel has been showing you is more like, do we even think we can measure it if it happens, right? Do we have any evidence?
Yeah.
Right?
Exactly. So
you should, I can share with you some of what I think will be around you work. We should actually talk, because we've done a lot of, it's not me, it's Barbara Snyder's. There's been a lot of work with some, I don't know if you've looked at.
We've
Yes,
looked at
we've
some
looked
of
at some.
it. It would be great to talk.
yeah, absolutely.
Our what we did, or she did, how we did, it was more focused towards what are they doing here in this particular activity, right? So at least you could reference that in your.
Yeah.
I think that's the interest, to me, that'd be really.
Yeah, my one critique of that is just that students experience a lot more in their academic lives than what happens in our classrooms. And so what we're trying to also acknowledge is that there's much more going on than that one really well-designed class.
Right, I'm putting my frame.
Yeah.
And I'm a designer, I have to put my frame on it, so what would happen?
Yeah, especially.
Thank you.
Yeah. I mean, especially as we start looking across, institutional boundaries, right? There's things like, academic advising that we know is important to that student experience, right? And so being able to catch something like that is why we went with the larger time frame. Yeah.
I guess two questions.
Sure.
That's right.
Of course.
One is I'm not a quantitative person, so this is really just sort of a question.
Sure.
So your large study has about 100 survey responses.
Yep.
Is that sufficient for valid, like, subgroup comparison?
Good question.
Like, because you're talking about, it seems like you've got lots of different groups in your sample that you're interested in, and so can you?
Yeah, good question.
Talk about that.
Yeah, so I ran a brief power analysis to see how many students we would actually want to do things like that. sorry, the question was, is 100 students in our large N sample enough for looking across groups, for looking into the validity across groups, right?
Yeah.
And the reliability across groups. And so my answer to the question is I have a sense of around 200 would be enough. And so we have some funding still left in from CREATE that we're going to do this again in the fall and really bump that up. But John's work this summer is going to start some of that, like, what is the method that we're going to actually utilize to investigate these things, right? And so that we have that plan so that when we get more data, right, ideally you just input the data and you get results.
And sorry, my second question was, you didn't really talk about the reflective interviews
Yeah.
that happened, and I wonder what sort of validity evidence you get
Yeah.
for both the ESM data and the journal prompts during the reflective.
Yeah, great question. Yeah, no, absolutely great question. So right now we've actually used the reflective interviews for validation of our survey and ESM tool and the coupling with the journaling prompts. And so I think we have, what did we run? 20 to 30 interviews last semester and have some rich validity statements from the students' perspective. We haven't analyzed that yet. Carissa is actually running a couple of interviews on Friday, the very last moment of the semester, with the students that we've followed longitudinal throughout this whole evolution. So we have 3 or 4 students that we have 3 to 4 time points. So across 2 years of their academic experience here. So Carissa will be doing those on Friday. Yeah.
This is linking to Kevin's first question, but also going back to my question about nutrition. For the people who don't take part, I would really encourage you, even if you get 200, right?
Mhm.
If you sample, if there are 300 in class, and only 200 did it, right? You still got only 2/3. And people could still argue that that is a bias sample.
Yeah.
So I really want to encourage you somehow to get a measure of the entire group.
Yeah.
And also that your subsample, right? Because if that subsample is actually equivalent to the whole group, that's wonderful.
Yeah. Yeah.
Right? But if it's not, then it's gonna.
I totally agree. I totally agree with you. Yeah. So I think, right, there's ways to do that, right? Like, as you said, get a measurement of what the demographics look like in that particular course, see what the demographics look like in our particular sample, and compare the two as a one-stop validity argument of the sample. Yeah, thank you. I don't know. I can't see if there's hands raised. No, it doesn't look like it. Okay. Okay, so I guess I'm happy to stick around and chat if folks want to chat informally. Thanks to people on Zoom for attending, and have a good rest of finals week.
Thank you so much for coming.
Yeah, thanks, Joe. Appreciate it.
It was
Yeah,
wonderful.
Thank
I
you.
didn't really realize you were doing this.
yeah.